All right. I can see that people are starting to join. Welcome to this session. Appreciate you all being here. I'm going to go ahead and turn the time over to Himanshu to give our presentation and introduce the topic.
Hi, thank you very much for joining. My name is Himanshu, and we have little time, and this is my first time in Nodes, so I was not sure how much to present and what is the expectation here. But this work is about an initiative which I took in the organization, and it started to, when I started working in data governance, it started to reveal that there was much scope of improvement and when we wanted to use the data properly. And naturally, knowledge graphs was one of the options. So this is a small pilot that we did, and it's based on my own initiative. So I work in the humanitarian and development sector, and one of the key challenges is that the data is very distributed. And when it comes to the location data, it's it's even more difficult. So I am trying to, yeah. So the problem, or rather problems, are at the global level, is that we have a large number of entity types spread across several countries. And when I say several countries, there are about 40 country operations. And of course, in the last several months, things have changed because of the funding uncertainties in the sector. And then there are multilingual names of administrative divisions in some countries. So for example, if it's Somalia, they would have local names in their own language, plus the English transliterations. If it's Senegal, then they would have French names and then English names. And if it's Latin America, they would have their own local names, but then also English names. And then because of translations, there can be very different spellings for the same location. For example, in Afghanistan, Sar-e-Pol can be spelled in different ways. Ursugan can be spelled in different ways. Nimroz, again in different ways. Hirata, and it's not just in Afghanistan, in almost all countries where the native language is not English. And then we get lost in transliteration. And then there are language-specific nuances, for example, specific letters in some languages and the accents on some alphabets. And then other challenges that the same named locations can be present in different countries, and that starts to create havoc as well. Then we have challenges at the organization level. That, of course, like any large organization, there's an organizational hierarchy. Then there's different systems which have different level of information about the organizational hierarchy. And it gets even more difficult when there's a possibility to enter free text, and that can be present in some systems. Then there's a question about ownership. And ownership is when challenge comes when we don't know who is responsible for what data type. And then the entity classification. Sorry, my animations are a little bit crazy here. Entity classification. For example, we have field offices, area offices, warehouses, guest houses, legal offices, some camps, and that makes it even more tricky. So how do we define a field office? Is it a legal office? And then it can vary from operation to operation. And then staff affiliation. So some staff may be working for some particular entity, but may be physically located elsewhere. And then there are staff attributes, entity attributes, which are spread across. And because of that, there can be duplicates, there can be missing information, and some systems and spreadsheets have more updates than others. And then a question of data provenance or lineage or origin, that creates a challenge as well. So practically the situation can be like this when it comes to data, and we wanted single source of truth. And of course, it doesn't mean that I have achieved that, but it's a work in progress. There's some trials which have worked. So it's an elephant, large system, or large organization, and everybody's perspective is different when it comes to data. So the rationale for knowledge graph approach in this case was because we have hierarchical and networked entities, and we have many interconnections, properties and attributes between different entities. And then there are many-to-many and variable relations. And in the sector, things change fast. And if something is hard-coded, that won't work for us. And then there's a need for semantic reasoning and flexible schema. And when I say semantic reasoning, it's also about connecting with external ontologies. And then, of course, we want to create easier possibility for creating intuitive queries across hierarchies, projects, core competencies, staff, etc. So, for example, example query could be what its staff have experienced in similar project types in neighboring countries or neighboring provinces in the same country. And of course, the long term is like any large organization, you want to be able to do some AI reasoning and use it for analytics. So the approach started when we started looking into master data management and data governance. And the basic is, got down to the basics, started almost from scratch. So get the reference data in order, getting control vocabularies in definitions, getting system owners on board, getting buy-in and ownership, because that's a key challenge. I won't say that it's all done and dusted, but that's a key aspect. And then lots of meetings, getting system owners on board and talking to different stakeholders, not just in the HO, but also across different operations. And all this to try to establish near truth with higher data quality. And automated locations, data collection of through systems, through API, and also manual annotations through meetings with diverse stakeholders. And so the components naturally were the ontology, started with ontology, and ontology can be very vast. So I started with a smaller section, adding the semantic layer for the shared meanings across different external ontologies as well. Yeah, these are some examples. And then metadata, which of course to add trust, for example, for the source, provenance, import dates, when it was created, when it was modified, who did it, and so on. And the stages, so in the stages were going from conceptual design, which took quite a while, and then moving on to an ontology design for a small subsection, and then creating data retrieval and integration process through API from different systems, and then semantic alignment with external ontologies, and then adding the metadata layer. And it's a new work, diverse. So I took a hybrid approach of Neo4j plus RDF or OWL, and naturally to translate RDF into Neo4j, I used the N10S for label property graphing and for Neo4j, sorry. So there was this, just as I mentioned in the beginning, it's first time, and I'm not sure how much to present. So I'll just give some snapshot of some of the core classes. May not be very visible, but for example, one example is for the organization, for the project, then person or staff roles, which are very important, locations, which is abstract, and then the country, province, district, city, locality, categories, for example, project or staff and organizational categories. Identifiers are very critical so that we have unique identifiers, and also assignment to develop relationships between organizations and projects, and who is working, who is assigned to what project, and so on. And then define key data key object properties. Again, some examples here for the structure and geography. Location is part, and then An example is locality to city to province, and province can be called county in some countries, oblast in some other countries. And also the disaggregation of province or administrative boundaries can vary. For example, in some countries it goes all the way to admin 4 level. In some cases, it's going only to admin 2 level. And then located in is one example. So for example, organization or project or site is located where, and then sub-organization, because of course it's a hierarchical organization. And then connecting people and organizations. So what person is assigned to what assignment, and the other way around. Yeah, I have 3 minutes left. Then assignment to the organization or component of the, or sorry, instance of the organization, and what role, for example. And then, of course, there are reportings in the organization. So who reports to who in what organization. Yeah, and for the project aspects, and these are just snapshots. So implementation of the project, location of the project, and of course, because of the sector, projects are funded by donors. And then there are partner organizations. And then semantics for external concordances. Yeah, and then the key data properties, for example, the common data properties are title, name, identifiers, created, date modified, and the person or ownership of that, the name of the person, family name, birth date, and so on. Project, so start date and end date of the project, and category of the project, core competencies, donors, and then locations, latitude, longitude. ISO codes are very useful for us, and then there are M49 codes provided by UN OCHA. And I must also say that administrative boundaries are also provided by UN OCHA and Food and Agriculture Organization. We don't have polygon set because that would create quite a lot of challenges right now. And then mapping for Neo4j. So it's a bit of a challenging part here. Animation. Yeah. So labeling to classes, organization, project, person, location, relationships among object properties. Yeah, these are some of the relationships, all the way to which organization funded what, and some code snapshot. Sorry for the animation. So for example, start with declaring indexes and constraints. This is a snapshot of some example code that created, then creating sample data and relationships. Then the relationships here, and some code snapshot for basic queries. Yeah, the time is running, so I don't know how much detail do I go into. But yeah, I hope I did it in the right time. Thank you very much.